organization which is based at Delhi. But Ravi is based at Bangkok, as you know, like he's with Apari. And
he was the Secretary General.
Executive Secretary, they call, Executive Secretary. So
we receive his newsletter all the time.
Right.
We are live now.
Right. So as a virologist,
Okay,
he said that, Sayyid, thank you. But I just want to say this, that as a virologist, he expressed that, like influenza, this C19 is going to stay there. We just have to learn how to live with this C19. That is what he mentioned. Yeah. Thank you. Professor Amit also had joined. Professor Amit, good evening to you.
Yeah, good evening, Professor Shah. Good evening, everyone.
Yeah.
I'm audible, I hope.
Yes. Extremely well.
Okay.
You have met Professor Gajendra Singh last time when he gave a talk at IIT, right?
Yes. I met sir there, I think a couple of years ago. Yes. I'll turn on my video just so that you can see me.
Hello, Amit.
Hello, sir. How are you, sir?
Good.
Good evening, Professor Tiwari. I am also coming from IIT Kharagpur.
Oh, very nice.
Okay, thank you. Professor Tiwari.
Yes, sir. I was Professor Satish Ball's student there back in 2005.
I see. Okay. I am here since 1984.
Yes, sir. It's been very long. Yeah.
Good evening, everyone, sir.
Yeah, good evening, everyone. Just
Hello, Vishwanathan.
Sir, good morning, sir, for you.
yeah, just couple of more minutes. We'll wait for some more people to join. Then we'll come back. Okay, you go ahead till this time. Talk.
Amit, by chance you have Vikas Jha's number, Amit?
Vikas number, I'll check.
Yeah, just in case if you have, could you please give my tinkle to join, because he may be in the field or something, so.
Okay. I'll call him if I have this.
Yeah, please, yeah.
Mahende sir, namaskar.
नमस्कार सर, नमस्कार.
कैसे हैं?
हाँ, बिल्कुल बढ़िया सर.
कहाँ पर इस वक्त हैं आप? बॉम्बे में? कहाँ पर?
पुणे
में. अच्छा, ओके.
Yeah.
Good evening, sir.
Good evening, Dr. Vishwanathan.
Sir.
नमस्कार, Dr. Gajendra Singh sir, नमस्कार. He's busy. Yes, Professor.
Yeah, Professor Shah, Vikas is joining. He just confirmed. He had some issue with Zoom. He said he's joining.
Yeah, thanks, Amit. Yeah. विकास, आप मोबाइल से ज्वाइन किए हो? विकास? Vikas, can you hear us? Amit, वो विकास ही है क्या?
Yeah, he is Vikas. I think he has joined through phone. Vikas, you should please rename yourself. We
Yeah.
see only mobile number.
Right. और अंधेरा भी दिख रहा है उसके यहाँ.
I think, good evening, all of you. I think we can start now. I think others will join. Thank you very much for joining today's session on the topic of automation in agriculture. Today we are having the 10th session. Every week we have one session. So we have crossed 2.5 months. And we started initially with conservation agriculture and urban agriculture. And last 3 sessions we are having from each university, alumni or the university currently working people, whatever they do, the research work which is related and applicable to the farmer centric, we are taking up. We are also plan to take up in the future some from the NGOs also. Our objective is very clear, to take all the research work and academic towards the farmer centric and to help the people, the generation, to mingle freely, to identify the issues and find the practical solutions. Now, actually, I will request all of you to push through. I will also be sending mails. We have a lot of work done on conservation and agriculture, and I'm very keen actually to get more speakers. Unfortunately, I could not manage to get from so much of international institutions which are working in India and spending so much money. They cannot find any good speakers voluntarily coming up. I'll be writing to them soon, and I expect more participation from the international organization working on conservation agriculture, what they have done till now, what is the reports. They are available in report format, I agree. But the question is to come and expose to our group, which is a group consists of all the important people and willing to work to course correct. So today we have an interesting topic from IIT Bombay, who have worked in IIT or who are working in IIT Bombay. This relates to again the agro industries, which was the topic which just last week I talked about it. I think it's very interesting. It's about dryers, another topic which is close to our heart. There's a processing and storage structures, automation, and this is basically towards the agro industries and rural development. So we have our good friend, Dr. Narendra Shah, who has coordinated to make this event successful, possible rather, I would say it's possible first. And I would like to invite Dr. Narendra Shah to come and continue with this program. Before that, I would like to request just Dr. Gajen Singh to say a few words to welcome all of you. Professor Gajen Singh, please.
Yes, good evening, everyone. Can you hear me?
Yes.
Yes, loud and clear.
Well, I don't think we should waste any time. We should start with I will make my comments later. Okay?
Okay.
Go ahead, Sayed.
Yes. Naren, please go ahead.
Yeah. So good evening to all the friends who have joined from from India, and those who have joined from outside. Good morning to them. Particularly, I think I can see Professor Gajendra Singh and Mr. Ramesh Deshpande. They are from US. So good morning to them. So last week we had a very fruitful session, and to me personally that was my Shikshan Bhumi. And today's session is from IIT Bombay, and this is my Karma Bhumi. I myself joined in IIT Bombay in 1992, and then kept on teaching, doing research, and sort of some extension efforts as the Agriculture University does. So when we had a successful session from both TNAU and MPKV Rahuri, I thought, why not with my colleagues, we can sort of propose a session. And as Dr. Said was saying, that next week we will have an NGO, and we will sort of we have talked to an NGO which is with track records for last 60 years of work, which was started by Mr. Manibhai Desai here in Maharashtra. And I think Dr. Syed will make the announcement later in the evening about next week's session. So friends, this evening you will have some 4 presentations, each around 12 to 15 minutes. And then we will sort of give about 30 minutes for question answers. So we will see if Dr. Syed as a moderator would allow after each presentation, or you can sort of collectively take the question answer session at the end. So so the 4 presentations are, one from myself. I'll be talking about, based on our own sort of, needs assessment surveys, and essentially through our MTech and PhD students. This is on a very old technologies of hot air drying, as well as some evaporatively cooled structures. I mean, in theory, all of us ag engineers have studied this drying. Even chemical engineers study, and the theory is quite well established. And I'll just take you through, narrate you some 2-3 sort of demonstration case studies based on the needs assessment that we developed a technology and tried sort of doing a pilot demonstration on the farmers' fields. Next is our colleague Dr. Amit Arora, who will talk about the onion storage structures, what are the opportunities and challenges. And this he did not only lab, but he took it to an ICR center in Maharashtra, and he will talk about them. Third is my colleague from Computer Science Department in IIT Bombay, Professor Kavi Arya. He is in charge of a lab called E-Yantra. And then later on, he will introduce his lab E-Yantra. And specifically this year, he has taken agriculture as a sort of, as the problems area. And he will tell about the competition nationwide, pan-India he conducts, and he will say it. And lastly, the fourth presentation is by one of our old alumnus, Vikas Jha, who did BTech from Raichur, Karnataka, Agriculture Engineering College, right, Vikas? And
Yes, sir.
subsequently, he did MTech at IIT Bombay, I think 2015, 2016. He graduated, and now he has a startup called Rucard. And then he will tell about his sort of journey as a entrepreneur or as a startup, what he has been doing. So let me try and share my screen. So Syed, I'm allowed to share the screen, right?
Yes, please go ahead.
Right. Okay. So are you able to see my screen, all of you?
Yes,
Right.
just
So
maximize.
yeah, I'll do that. I'll put it in the projection mode. So
But it's showing only 6 to 40 minutes time limit. Your slide projection is not there. You
Is
run
not
your
there?
slide. No, you run your slide, then start. You stop sharing now.
I
First
stop
stop
share.
share.
Okay. We'll go
Now
to
run your application first.
Is it okay now? Is it coming?
No, run your application, then go to Zoom. Then go to Zoom and share screen.
Okay.
In Zoom share screen, click. You're not doing it.
Yeah, I'm there now. Share screen, and I'm sharing.
Yes, it's okay. Fine. Go ahead.
Are you able to see now? Yeah.
Yes, please go ahead.
So this is like, as I mentioned, we know this, in the sort of, in the second chapter of our textbook in food process engineering, when do a course, we have seen, for example, not only in textbook was, the applications like this. You see the fish being dried at the coastal places, and you have the instances of these evaporatively cooled structures. In fact, IARI, Dr. Roy had developed sometime in 1986 this zero energy cooled chamber. So the theory of this is something, as I said, like in the second chapter, we all studied what is water activity, and we all know that if you keep the water activity below 0.7, then all these perishable commodities, they store well, and you can sort of, not have any of those microbial attacks, which really is one of the culprits. So water, then to the water, you have these microbes, and microbes spoil your sort of, happiness of the farmers, that they produce whatever produce they have. So during storage, so, based on the perishability of the material, let's say, your cereals can last for 2 to 3 months without having to sort of store in any cold place. But if you have fresh vegetables, 4 days, 5 days at the most. If you take tomatoes, for example, you might have a shelf life at ambient temperatures of 3 weeks or so. But if you really want to extend, then sort of, you really have to sort of put them in the cold. And often at times, for example, that the villages have still within India are struggling to have a sustained electricity supply and things like that. And you will see. So this is something which I have just shown what we know from science of water activity. And now the first, for example, application I'm going to tell you about is the hot air dryers. Okay, and the hot air dryer, how we sort of integrated or solved a problem expressed by an industry. So this is such a live problem. I'll show you some images which I received just 2 days back, where we are sort of, so this is the case one, development integration of hot air dryer for drying treated cotton stock post-treatment in ozonated water. And in a minute, I'll tell you why we are doing this ozonation of cotton stalks, which normally are burnt, or at the most you have briquettes, for example, which are used in the combustors, in the boilers and things like that. But we have developed a new application of value-added product from this cotton stock, because if you for example, make briquettes, you might get at the most 5,000 rupees per ton. Whereas if you sort of make an animal feed from this, you can go something like 15,000. So 3 times higher, 15 to 18,000 rupees per ton. Okay, you can get that. However, all of us know, those who are from Vidarbha area, cotton growing areas, we know that cotton stalk gets as hard as wood because of its lignin content. And therefore, no animals would want to sort of touch that because they don't eat woody substances. Therefore, we sort of did some research and we have developed a technique or technology. I'm going to talk in a minute. And the case 2 is like, we call it typically NPD, new product development. And we have sort of, this potato puffing unit for small agro entrepreneur. And I'll try narrate you, I'll take you to that. So this is the case study 1. I said to you the project on making animal feed unit from cotton stalk. Last almost 5 years, we have worked on this, and it has traveled its own journey. First in the lab, we did trials for something like 1.5 to 2 years. And what trick the ozone does is it chops the bond between lignin and cellulose. So as a result of this chopping the bond between lignin and cellulose, the cotton stalk, I think Professor Mayande would so much appreciate because he lived in Vidarbha, and the same as Vijay Patil. Those who have lived in Vidarbha, they know that cotton stalk farmers, then they're so much bored or tired that they want to release that land for next crop. They just burn it. So and what happened was, this was kind of a serendipity for us, like when we were working on this, reducing the microbial load using ozone for tomatoes, we just sort of tried this and it worked. And subsequently with the Nagpur Veterinary College, for example, we did a pilot plant and studied it on small ruminants like goats. And it was sort of, a kind of such a pleasant sort of, outcome of that project, that the Maharashtra Science and Technology Department, RGST, as we call it, Rajiv Gandhi Science and Technology Department, gives a 2 crore. And with BIF, which I mentioned to you in the beginning, the NGO, we are now developing a plant which is in the process of working there, is for bigger ruminants like cows. So with goats, for example, our study outcome was how fast is the weight gain, how fast we can gain weight using this animal feed. And we did a systematic control trials that we compared cotton stalk versus the other sort of, conventional feed. And we did that. And now we are sort of, and why, for example, we need a dryer here is because we had done this. This is a ozonated water, which does the trick. And the initial design was to have the sun drying, because in rural areas, normally there is no sort of scarcity of land. But you see what has happened in this rainy season. This is a picture of yesterday. Even in dry, for example, district like Pune in Western Maharashtra, it doesn't rain like Konkan or Mumbai. Look at the fungal attack that you have on the treated cotton stalk, because the treated cotton stalk, which is removed from this ozonated water, it has the initial moisture content of something like 85%. And we need to bring it down to 15% because the briquetting machine has to sort of, work. And the briquetting, other ingredients like, the oil cakes and things like that, which we make a complete feed, it has to be brought down from 85% to 15%. So what we have done is we have sort of designed a simple dryer, which has a capacity of 200 kgs, because that is what they want to make. In 5 hours, for example, we sort of bring the initial moisture content from 85 to something like 15%, which is something which our pelleting machine can take with other ingredients. Because all food processing engineers, agro processing engineers will understand that if you have various ingredients, the moisture content should be kind of sort of uniform. You can't put something with 85% and something with 10%. So we had to sort of, because we are making this pellet in the same way as the animal keeping farmer has been used to. So there is the animal feed which comes in pellet form. So we have not changed much there. So 60% of our ingredient that goes into making this complete feed is this roughage, as it is called roughage. And cotton stalk was never used. And last 5 years, as I said, we are in the process of doing these trials with this. So this is, I sort of demonstrated to you, it's a live problem, how, for example, a hot air dryer can be designed and integrated in an agro industry to solve a problem. Now, the second case where we integrated the hot air dryer is what we call in NPD, is like, for an agro industry entrepreneur, we sort of said that you can make puffed potato cubes. And I don't have a video, I don't have a time to show you a video, but these are again something which is known in other chemical engineering industry, for example. This is a fluidized bed dryer. Okay, and the end product you get is something like cheese balls, which are rounded. So you can imagine, you take potatoes, you cannot have round balls. So what you do is you take cubes of 1 centimeter by 1 centimeter, 1 centimeter. I mean, this is the average size. You can have up to 2 centimeters, 2 centimeters to half centimeters. As an academic institute, we tried various combinations. So 1 centimeter by 1 centimeter gives you a kind of a snack which is similar to the cheese balls that all of us have seen and used. So this is a unit that we developed, and this had a hot air dryer. As you can see it in this photograph, this is a blower which blows in the air in this a compact air heater, and this air which is coming out makes this, this is the container where drying and puffing takes place, and the potato cubes dance inside this. And as you can see in this performance evaluation, so this is again another sort of, cut schematics of this. You have a blower, then this is a compact air heater, and it sends the air. And what we want to do is, like, there is different drying temperature requirement is different, and the puffing temperature requirement is there. So as you can see, between 3 to 4 to 5 is what you call HTST process, high temperature short time. Which is like 4 to 5, which is that 170 degrees Celsius for few minutes we keep it, and you get that puffing effect. Otherwise, in a batch of something like 200 minutes, about 3 hours, you have most of the time is drying. Okay, so these are various steps, and the process engineer, you always do some kind of a TT diagram, time versus temperature. And as you can see it here, and this is the entrepreneur from Vasai has taken it. But that was another story, that why he could not capitalize on this, because simply he did not have a 3-phase connection in Vasai. But this is a second application. For example, I have just actually taken from A.S. Muzumdar's handbook a selection of dryers, and I don't have to deal, I'm not going to read through how, for example, one goes and selects a type of a dryer. So like in our application, we had the fluidized bed dryer, as you can see here, the 4th one, fluidized bed dryer, for this potato puffing, because it gives you higher mass and heat transfers, because you want to come from 85% to 15% moisture. And at the same time, you want to sort of, use minimum electricity. So because in drying, one of the important thing is like energy use. So you want to have a specific energy consumption, which is lower. So there is some kind of a sort of, this is, I have just taken it from A.S. Muzumdar's handbook, dryer handbook. Those who want to sort of work with industry, select a type of dryer, and like what we did for our ozonation project on converting animal feed from the cotton stalk. That is how we designed and sort of, Now with this, now I will come to my technology 2, after having talked about this hot air dryers, that how intelligently you can use. See, what I tend to tell my students here during the teaching here is that enormous amount of literature is available in the handbooks also. You just only, it is waiting for, developing those applications. I mean,
and you have 3 minutes. Sorry,
3
you have
minutes,
3 minutes.
So Perry's handbook, for example, in chemical engineering, will give you, something like 800 pages. You have so many tables, so many data, and all that you can use. So this is a simple application. What you see here is a evaporatively cooled structure. What is innovative in this? What is new in this? We have taken the locally available laterite blocks. People build houses of this. So what we have said, that because this is thick, so you keep a gap in between these 2 blocks, which will allow the air to move. And we just simply took a drip irrigation system and dripped the water frequently using some automation process. that I'm going to, and we did some kind of a, needs assessment, like why the farmers, for example, 20 farmers could own the 3-ton structure to store their vegetables of 5 days product. And so they can sell it in a markets which are at distance and get the revenue. So these are the kinds of vegetables that the farmers stored in this. This is how the structure looked like of 3-ton capacity. And then, of course, like we did an academic study that what kind of temperature variations, as you see, for example, the red dotted line shows you the temperature, which is of 20 degrees Celsius, and which is like, you can get something like, 10 to 12 degrees Celsius of delta T, which is largely good enough to extend the shelf life. And along with temperature, all of you know this fundamental, that also relative humidity has to be higher. So, on Nukkadwala vegetable shop in months of April, May, he just keeps sprinkling water on it. What he does is he increases the relative humidity so that the vegetative cells are kept, and you don't have that wilting or shrinkage of those vegetables, and he can. So this is some little summary of this evaporatively cooled structure. You have 3 tons, and I said 20 farmers, because that's based on what they produce. I mean, they get about 20-30 kilos each. And so they can own it as a farmer producer company to store it for 5 days and have additional revenue. This was the size, and water required is about 250 liters. And you can also recirculate the water after filtering. And the installation cost was 1 lakh. And we just did some calculation. This was just last year. Samir did his MTech and passed out, and sort of, this is in the first year of use, but we do know from the collector's office in Palghar that they are using it, and the payback period is about 4 years, taking that delta revenue addition. So Syed, this is my last slide. I'm acknowledging my student who helped sort of, conduct these needs assessment, farmer group, like focus group discussion with the farmers, and sort of telling them the use of this, making the measurements in the field. Thank you for patiently listening to me. And I will, Dr. Syed will sort of, announce when you can ask questions. I am ready, but Dr. Syed, your call.
Okay, I will. Thank you, Dr. Narendra Shah. Can you stop sharing your slide, please? Okay, thank you. Thank you, Narendra Shah. It's interesting in 2 points. I see first is the cotton stalks are being used as a nutritional, as a feed for the animals. This I remember I heard in Sirkat when I was with you, I think a couple of years back. Right. It's interesting, very useful actually for the farmers because they have problem. I also came last 1 week from Vidarbha area only. Now, second point I see is 2 years back I heard about the NABARD was financing the buyers who are carrying on the cart vegetables, how they can keep it longer by a solar cooling device, something. And I think there were not many people who came up with that, but your idea is excellent. I think we'll discuss all these questions, we'll keep in the last, because let us see, all 4 are very related topics. So if we should not delay very fast, we'll have all the presentations. I would like you to introduce the second speaker, please, Dr. Narendra Shah.
Yeah, so it's a very pleasant duty to introduce my own colleague, Professor Amit Arora. As he did his MTech in IIT Kharagpur. I do not know the years, and then subsequently did his PhD in US, and then came back and joined in Sitara, I think around 2013. So Professor Amit, quickly you can sort of introduce yourself, your topic, and then sort of 10-12 minutes is yours.
Yes, I can see the slide. You can make it bigger if you want, or if you are comfortable with this, fine also. It looks good, no problem.
Sorry, I was muted. Good evening, everyone. I'll make it full screen. Yeah. So good evening, everyone, and thanks for inviting me to speak among all of you. I mean, you are all experts here, and what I'm going to present here is going to be very short presentation regarding the most pressing problem in Maharashtra. Onion, a lot of farmers in Maharashtra and elsewhere also, you will see that they are struggling with the when it comes to pricing of onion, there is so much volatility involved in that. So somehow we just got into this problem, and a couple of MTech students looked at this problem very carefully from the point of view of value chain analysis, and realized that there are a couple of things that needs very serious technological intervention to take care of most of the issues that are involved in onion value chain. So I'm going to present that in next 10 minutes. Will be very, very brief, but I'll be open to questions later on. Thank you. Regarding my introduction, I think Professor Shah has already mentioned. My training is in agriculture engineering. Graduated from IIT Kharagpur back in 2005. Went to US, University of Illinois, Urbana-Champaign. Did my PhD there in mostly does food and bioprocess engineering in bioenergy and biofuels area. Worked as assistant professor at University of Wisconsin for a couple of years before coming back to India. So that's in short. Okay, so here, so my topic says it's a climate agnostic onion storage structure. And let me put a context to it. So if you look at, today's situation for farmers, onion growing farmers, you will see that there are more than 30 to 50% losses in the value chain itself. Because that does not happen only on the farm, but across the value chain, losses are very, very significant. And we all are very well aware that how onion prices volatility is so very significant. Onion can be bought at 5 rupees per kg in a given season. And the other side of the spectrum is one may have to shell out 120 rupees to get 1 kg of onion. So that's the reality. But this money doesn't really go to farmers' hand, as we all are aware of that. So that was the context given to us after doing a couple of years of value chain analysis in this area. So what we realized is, so there were certain issues when it comes to storage of these onions. So this was a part of our study my couple of MTech students did. They realized that, so there are 2 seasons essentially when onion harvesting happens. One is Rabi and another is Kharif. So Rabi season is essentially harvested in March and April and stored till almost till Diwali. So for 6 months, one need to store it, and then you will get Kharif onion. The harvest of Kharif onion comes out after Diwali or near Diwali. So how do you store these onions for 6 months? That has been a challenge. And why this has been a challenge? I think this is an agriculture community, so you understand that there are both pre-harvest and post-harvest factors, that contributes to that. And I don't get into details, but important part here for me to point out is, if you look at right-hand side post-harvest factors, we have curing and storage conditions. So these two actually contribute very, very significantly in deciding the shelf life of this produce. So why curing and why storage? These two things I have mentioned. If there is a negligence on curing side, basically when you pull out the onion from during harvest, you leave it in a field so that it gets dried naturally in sun drying, and then you will go for storage. It's a ventilated storage structure system. So what is reported in last few years, this is data coming from Directorate of Onion and Garlic Research, Pune. So about 35 to 40% losses have been reported in this area. So of course, there is a solution to that. You can do artificial, artificially you can cure it in a drying system. You can have an artificial dryer where you can do this, and you can get rid of these problems like black mold, bacterial brown rot, and all things like that. Now, why field curing is not good? There are several reasons. You can clearly see you cannot control temperature and relative humidity, just like Professor Shah mentioned in his previous presentation. There is no way we can control these variations in temperatures. So especially diurnal changes are very, very huge. Field is occupied for more than 2 weeks, and look at this graph that clearly shows. This is a field visit data that we had. For same day, you will realize that how much variation is there in temperature. Okay, it's very, very, very significant. And this is the field data that you see here. So what we thought, let us, rather than, okay, sorry, I think I have missed one slide. Anyway, so rather than having this, all sorts of variables controlling us, let us control those variables and be able to see whether we can manage to improve the shelf life of onions. So here comes the idea of developing a climate agnostic storage structure where we can control these parameters like temperature, relative humidity, and other physiological weight loss parameters and things like that, so that we can give right environment for onion to thrive. And so sprouting and rotting losses can be minimized. So we developed this tier system, which you can see on the right hand side of picture. And this was done at IIT Bombay. We also have a signed MOU with DOGR. So we worked together and developed this. So if you really looked at what we did is we designed and developed the system, then we did performance evaluation, and then we also did techno-economic analysis of that. So this is typically what you see in India, whether it's Maharashtra or UP or MP, wherever you go, you will see this on the left-hand side. These are the traditional storage structures which are plentifully available. Unfortunately, they don't do the trick because it's all open to the environment and you can't control temperature and relative humidity. In a state like MP, it's still okay because you don't get rains like Maharashtra, Mumbai, or Konkan area where you have more relative humidity. Wherever there's a dry region, you can still able to manage it. And the concept that Professor Shah was talking about, evaporative cooling, that may do the trick. But in other regions which are more susceptible, where you have high relative humidity and temperature, then it becomes much more difficult to handle. And that's the reason we thought of doing some experiments. So these are just some, our initial days back in 2016, 2017, when we started this project. We dismantled one fridge to see whether we can develop something very small. Then we actually, installed one full system in DOGR itself. The system is still there. If you can go there. There were many challenges when we were doing this, because challenge of maintaining not just temperature and relative humidity, but also making sure that you get good amount of fresh air pass in the system, because onion is known for releasing these gases that are troublesome. And so a lot of engineering was involved. We did CFD analysis and figured out what is the best orientation, what is the best flow rate, how much air should be passed through each tier of the system. So we developed this CFD analysis. This is the storage structure that we came up with. Of course, you can see here, maintaining RH is very important. Sometimes you see that relative humidity is not enough, and that basically reduces the overall weight of onion. So farmers will lose on the price. So I think maintaining RH was also very, very important. So we followed some experimental designs. For want of time, I won't get into that. Just to explain you. So you see there are two words, AC and C, and then AS and NS. AC is artificial curing. NS is normal storage or natural storage. And AS is artificial storage. And NS is, AC is your artificial curing. So we took this essentially permutation combination, natural versus artificial environment. And we did this trial with all, with all experimental design. These are the lab pictures. We did, we did this controlled study with proper sampling and everything. So these are just snapshots just to show that we actually did this properly. And what we got was very, very exciting. If you look at the final results, which is shown in this slide, so the rightmost, natural curing plus natural storage, which is the conventional method of doing, you see the sprouting losses are more than 20%. When we compared this with the best environment that we had, artificial curing plus artificial storage, losses were about 5%. So clearly the 20%, you see the losses that are happening because of this, that can be cured very well using this AC plus AS condition. So that was our finding. This is about sprouting side. About rotting losses, we did this study for last, I think this was the third year when we were running this. So we are able to save about 15% to 20% of onion there compared to traditional structure. That's again very, very significant. So if I want to sum it up, what can be done is instead of using a traditional storage structure, if you shift from that to climate agnostic, very well controlled environment structure, then this huge amount of savings can be realized. Having said that, I should also mention that this will make sense only when we are targeting at least 100 tons of storage structure, because otherwise economics doesn't fit very well. Okay, so that is one of the outcomes in our techno-economic analysis. For want of time, I would not show that. So let me just close it here. One more thing I would like to mention here is, so we have successfully demonstrated 3 tons and 20 tons also with DOGR. Now we are working with the Parbhani Agriculture, VNMKV Parbhani, to set up 100-ton unit. And we are also working with the Pokhara government of Maharashtra project on climate resilient agriculture with the project director there. It's a World Bank funded project. So we are targeting 500 tons to 1,000 tons of storage structures in different parts of dry land areas in Maharashtra. So this is an ongoing work. I mean, we didn't realize that an MTech project can go this far. So we are happy about that. So I'll be happy to take questions. Just one quick slide I'll show. We were also doing something related to, I think Professor Kavi Arya will talk about that. How can we also empower our farmers to design and develop a forewarning model or system for onion storage losses? So suppose onions are going to spoil in next 3 days, they should get an alert that, you know, this is the right time when you should sell it off or make some better use of it. Otherwise, it's going to cost you much. So this was a work in progress. Because of COVID, we had to stop it. So we did some basic work here. And hopefully, after this lockdown and all, we will continue to do that. Okay, I'll stop here. Thank you.
Thank you, Dr. Amit. It's a very interesting topic, and it's a topic of the need of the day. Because I know as I've traveled recently to Buldana and Wasim district.
Yes.
And I know the problem of, this is one of the projects actually everybody is looking for how to store it and get the better pricing for the produce. That is what everybody is looking for. We'll shift to the questions the last, because I think it's going on good speed and everything. I think we'll have a long session of discussions, questions. If you can stop sharing, that'll be good right now. Okay.
Sure, so thank you very much.
Excellent. Thank you. You hold on, please. We will finish the next 2 speakers, then we'll come for questions. I would like to request Dr. Narendra again to call your 3rd speaker, your colleague.
Yes,
please.
Yes, thank you, Syed. So Professor Kavi Arya, as I mentioned earlier, is our colleague in CSE department, Computer Science and Engineering. And just at the beginning of this webinar, he mentioned that 1 year he took a lien from IIT and spent as an advisor to Mahindra & Mahindra for a year. And I think perhaps, I mean, I understand that would have been a kicking point for him to sort of take agriculture as a part of his e-yantra developments. So Professor Kavi Arya, please introduce yourself and take 15 minutes on telling us what your robots and automation devices can do in agriculture. Thank you.
Great. Thanks, Narendra. My name is Kavi Arya. I'm a faculty in the computer science department. Not very much to do with agriculture, I'm afraid, but have a lot of potential to offer. And we've been discovering what that potential can actually do with colleagues like Amit Arora. Right? He just mentioned a little bit about the possibilities. But I teach a subject called embedded systems, which is building machines with some intelligence inside them. And I've been doing it for the last 2 decades at IIT Bombay. And I was also the program coordinator of the distance education project at IIT Bombay many years ago. And I tried to teach this very practical engineering subject through the distance education program. And it was an utter flop, an utter failure. I won't go into the long and short of it, but in addressing that failure, we've discovered an amazing way to teach very practical subjects at a distance by giving essentially the students a little device on which we give assignments, a little robot, if you like. We give assignments on the robot and the student can learn everything. And nowadays, we've gone beyond that. You don't even need the robot. You can do everything inside a simulator. So we can, in a very scalable way, teach hardcore engineering skills through robotic technology, simulation technology, and what have you. And simulators are not toys, because a pilot doesn't go just fly a Boeing aircraft, right? He flies on a simulator, then goes into that. And simulators have become, compute power has become so cheap that simulators can give you a very real experience of a problem. So that's where my story begins. And I run a project called e-yantra, which is a robotics outreach project from IIT Bombay. And the reason I'm here to talk to you today is that we've reached a very interesting point where we've learned how to train large numbers of students with robotics and related skills. This year, we would like to combine these students with agricultural problems, with agricultural universities and agricultural faculty and students to solve real problems. The fact is that agriculture is a space which is not yet been exploited the way it should, in India at least. And I've spent a year as a technology advisor, CTO in Mahindra and Mahindra, way back 2007, when I discovered a lot of things which were part of the reason why I came back to IIT and began eYantra. So let me just share my screen and I'll tell you what I mean. I'm going to play a few small video clips, so please bear with me. I hope you can see my screen.
Yes,
And my voice is clear
yes,
enough.
go ahead. Yeah, go
Okay, so
ahead.
this is the goal. The goal is to create student innovators for local disruption. Local disruption in any area, agriculture is just one. We want to create students who can turn problems into opportunities, okay, essentially. And the reason is because we have an exponentially growing economy. It's taken us 60 years to become $1 trillion, then 7 years to become 2 trillion, and 3 years to become 3 trillion. And there's a huge demand for products and services which need automation. And as you know, anything that you do indigenously, you can do it at 1/8 the cost of an import. And we had half the population is below the age of 25. 1 million engineers almost graduate every year. So we actually have a lot of manpower, but unfortunately they are the ratta maro and examination pass karna kind of engineers who can't really deal with real problems. So we need to change that. And the other thing is that low skill jobs are under threat because of AI and automation. Every sector you look at, all the Godagiri jobs are going to disappear, including software and so on. And let's not go into that, but so these are the skills that we try and train students with at scale: design of solutions, investigating a problem, using modern tools, working as a team, communication skills, highly underrated in our education system at the moment. And we do it through competitions, 6-month-long competitions that actually teach you these skills. This is just a short, I'll be playing an excerpt of a video of one such student who's touched by us. There are many, there are about thousands of them. Shruti Joshi came from IET Lucknow. She took part in the competition, took part in the internships, and this is what she had to say.
When I just got into engineering, I had a lot of hopes that being an engineer means I'll be solving problems, or I was an electronics engineer, so I was expecting that there would be something related to robotics or IoT or something. But it was just like we are passing semesters, studying for semesters, we have 2 or 3 labs, but none of that was related to the level of work that is done in the industries. Getting to know about eYantra was a game changer for me because I got to know about so many technologies in my second year itself. Before eYantra, at 4:30 our classes used to get over and I used to rush home. Before 5 p.m. I was at home. But after eYantra, we used to stay at college like till 7:37, and we also asked our HOD to allot us a room where we can work.
We'll just go ahead.
Been like an added advantage for me in every field, and also the biggest contributor in my resume because my project section is full of projects that I did in eYantra. I gave 2 interviews in my final year and I cracked both of them. The project that I shared with my interviewer was the project that I did on robot operating system and with drones. So firstly, not many people are familiar with what ROS is. So they take a lot of interest in knowing exactly what I did in my project. So that discussion went for a very long time. While I'm explaining it to them, if they are understanding, they themselves know that, okay, I've worked on this project thoroughly. That is why I'm able to explain it to them. So there were not many counter questions on that. But the thing is, they were pretty impressed by the technologies that I've already worked on. more than proving anything to your employer or anyone else, I think at the end of 4 years, we always ask ourselves, what did we do as an engineer in the 4 years of our engineering? So you feel that you're not actually implementing anything, you're just into bookish stuff. I would say that eYantra is that one thing which will give you the exposure, is the biggest contributor to the practical learning and real world problem solving skills that I have built as an engineer. So that is what eYantra has given me in the past 3 years that I've been involved with eYantra. So yeah, it has been a blessing for me.
So that's what we do. We teach robotic skills through a competition which lasts 6 months and is transformational for most of the students. And when we started registrations for our competition 10 years ago, these are the kind of response we got from all across the country. And we teach these very real skills in a project-based mode. That means kids are actually solving real problems using these skills like image processing, machine learning, control system design, FPGA design, all sorts of things, right? This is the way the student engagement has increased from 4,000 registrations in 2012 to almost 34,000 in 2019. And because of COVID, we got hit last year, but almost 1,364 colleges have participated, and the prize is 6 weeks internship at IIT Bombay. I won't go into details of that, but this gives you a typical idea. What we do is that we teach student relevant and contemporary skills. Like most of the drones that you get, they don't allow you to have access to the actual sensors and actuators and motors and all that on the drone. So we partnered with a startup at IIT Bombay which does nano drones, and we got access to the entire sensors, actuators, and then we actually taught students how to build a drone control system to make it hover and then move from point to point to solve a problem. And this is the kind of stuff that they did. So this is what the skills are that we teach, and we have students who've taken the same skills that they've learned in the competition, and they've done startups. Like there's one startup, Drona Automation, which does sewer cleaning robots, Nebrus Technologies, which does surveying of mines. We have Catamaran Technologies, which is building mobile robots in Coimbatore, and so on, right? And this gives you an idea. This is Nebrus Technologies. He had built a beautiful surveying system where the drone autonomously, you just mark out on a map the area that you want surveyed, and it automatically divides that area up into strips, and it flies around that area to actually record a video. From that, it derives the volume of material which is stacked in that area in a mine. Okay, and this is the patented launchpad that he built, right, to recharge the drone automatically. So I won't go into all that now, but these are the kind of things that they do. And every year we have themes. Last year was an Industry 4.0 theme. This is a typical theme. COVID lockdown May, we were able to teach how to build drone control systems. And deploying a drone inside a simulator. Here we are using an source simulator to train in real skills. Anyway, that is real engineering skills. This year, the themes are based on agriculture, and we have things like strawberry stacker, because we found that what lowers efficiency when people are picking strawberries or other fruit in a field is having to run with a little basket to a parked vehicle, right? And so we thought, why not have drones do that? So this actually helps you build an application like this inside.
Sorry to interrupt. You have a couple of minutes to.
Yeah, sure. I'll wind up very soon. Right. Yeah. So we have an AgriBot, which is a UR5 ARM-based robot that actually navigates in a greenhouse, plucks tomatoes. I'll give you an example of that. We are setting up labs, which are local innovation ecosystems. We've established about 400 plus labs across the country. And we have the robotics competition teaches you skills. The innovation challenge trains you to use those skills in solving problems in particular domains. Last year was disaster management. this year is agricultural automation, right? So I'll give you a little bit of information about that. We do that through education platforms that we build. So what these education platforms do is that they let engineers prototype a real application in a short time, something which will take them 2 years. If they had to build everything from scratch, they can do in 1 month's time. So we have an IoT platform, we have a mobile robotics platform, which is here in the middle, and then we have all sorts of other platforms. I won't go into details of this. But this is what we have for harvesting fruit inside a greenhouse context. This is our AgriBot. The mobile robot here is built by an eYantra alumnus who's got a company in Coimbatore. The arm has been taken off the shelf. So this is our rapid prototyping tool, if you like, which can help you solve these kind of problems in the context of a greenhouse. Okay. So I won't go into details of this, but we have an IoT stack from sensors right up to cloud, which is free of cost. Usually you have to pay a subscription, but here we show you how to build an IoT system totally free. We built a farm at IIT Bombay, which is totally controlled over the net, over the web. We built our own sensors, actuators, and all that kind of stuff. And we are incidentally having a hackathon with agricultural scientists on the 21st of September from 10 to 1, where we are going to brainstorm and curate a large laundry list of interesting problems in agriculture, which then we want to feed into our competition and combine one agricultural science student with other engineering students to see if we can collaboratively solve problems. So the whole attitude of eYantra is that jobs are in short supply and we need people who are entrepreneurial in their outlook. We train through experiential learning, through competitions, and we try to create this problem solving mindset, right? So there are lots of challenges which need to be sorted out. Lastly, I'd like to say that Amitabh Bachchan in Padman film said, if you remember, we don't see us as 1.3 billion mouths to feed, but 1.3 billion minds which can engage in Avishkar. And we have a team of about 35 young students who does this whole thing at IIT Bombay, right? And it just shows young people, if they are suitably motivated, can do a hell of a lot. So my case rests there.
Thank you.
I'll be happy to answer any questions as to what I am doing in this agricultural venue now.
Okay, thank you, Dr. Kavi Arya. I think it's interesting. Unfortunately, this particular forum is for all professionals in the line, and this will be very useful. I think the teachers can take this to their students, who are professors here in this forum. We'll come back to the questions as I told you in the end of the session. We have one more speaker, and he will talk about the field experience dissemination of subjects. Kula. I would request Dr. Narendra Shah to introduce the last speaker, please.
Yeah. So Vikash, are you there? Can you raise your hand, Vikash? Are you there?
Yes, sir. I'm here, sir.
Right. So Vikash did his BTech from Raichur, Karnataka, and then subsequently he did his MTech with us at IIT Bombay, completed in 2015, 2016. And since then, I think he never took any job, but he sort of went as an entrepreneur. And now he has set up this startup called RuCard. And he will tell us about his journey from since his MTech time till now, what he is doing and what are the challenges that he is facing. Vikas, please, 15 minutes. Yeah, 12 to
Thank you, sir. Thank you very much. So I am Vikas Shah. I did my BTech in agriculture engineering, as mentioned by sir, from Raichur, Karnataka, and completed in 2014. Joined IIT Bombay at Sitara for my master in 2014-16, and since 2016. I was working with one of my professor at IIT Bombay, Professor Satish Agnihotri, to develop technologies which will be mostly suitable for small plot farmers, less than 2 hectares of land. So we set up RuCard in 2019 with 3 IIT Bombay alumnus and 1 from IIT BHU, which is a B2B2C agri-tech. And currently we have our revenue of about 2 crores, and we mostly develop the scalable green technologies. So why we have been coming into this field, as we all know, and most of them are of us are agriculture engineers. 40% of the fruits and vegetable wastage, which significantly lower down the income of the small plot holders, even less than 12,000 rupees per month. And when we say that 40% of the losses, this is from the monkey's view, bird's eye view. When we look at from the worm eye view, And this is a study supported by NABARD in Maharashtra and Odisha. We found out that about 60 to 70% is happening at the farm gate only, where in transportation about 10%, and then the retail again 20 to 30%. And when we were looking upon the solutions which will be fitted for the small plot holders, we found that there is a lot of innovations coming into field, but they are mostly towards from in the last mile, from the warehouse to the kitchen, that is the PCM based, phase change material based, and the electric solar cold storage and the blend solar cold storage is acting as a collection center or for this commercial purpose or for the large farmers. That leaves the small plot holders less than 2 hectares of land with very few choice or almost with no choice. So with three students under the guidance of Professor A.W. Date, we started running experiment in 2017 at IIT Bombay in my department Sitara lab. And we were looking upon this need of the small plot holders across the states like Karnataka, Maharashtra, Odisha, Jharkhand, Bihar. We had 3 aims to make that atomized cold storage. When it comes to atomized, the farmer has the notion that like the atomized irrigation sources like dug well, bore well, change the irrigation scenario in India in the late 80s, 90s and early 2000, the same way the atomized storage solution can change this context. Then they were looking at the recurring free cost technology and with the minimum maintenance. So we come up with the subji cooler. We all know that most of us agriculture engineer again, that food degradation increases 2 to 3 folds with every 10 degree rise in temperature. And in the subji cooler, which is evaporative cooling based technology, we can lower the temperature anywhere between 5 to 23 degrees. A report by MS Swaminathan Research Foundation pointed out that most of the farmers are getting about 30 to 50% higher income after getting this subji cooler. And they find out few points, key points why they are getting this higher income. Because they have the better holding time. You can store the produce for anywhere between 5 to 7 days in the subji cooler. The subji cooler is weighing just 50 kg. Farmers are using it as for the logistic purpose also. So they take it into the small Chota Hathi or Tata 407 and transport it to the middlemen or the buyers, and then take it from the take it back. So help them in logistic support. And when you have the better holding time, you have more time to access to more market channels. So earlier they were supplying only to the middlemen. With the subji cooler, they also start supplying to the small shopkeepers in the district level of market or the block level market. After 5 or 7 days, the produce looks as fresh, as attractive as it was just freshly harvested. And thus with the seller, the buyers are also happier. So this brings dignity and happiness to the buyers also. So far, Rukat has installed more than 300 subji coolers across Maharashtra, Telangana, Odisha, Jharkhand, and which enable them to enhance 300 to 50% more income. 500 more units are in pipeline, and we do hope that because of this disruption in due to the pandemic, we could not supply that. But before the end of this financial year, we will be able to reach out to 1,000 plus customers. Wherever we have demonstrated our technology, out of every 3 demonstration, we will able to get order from the 2 demonstration. Since inception, about 33% of our customers are repeated customers. With this, we also got very much media attention because of this increase in income. So from the Hindustan Times to the Hindu and all the local media persons also have covered our impact stories. So this is all from my side. Thank you very much.
Thank you. Can you tell me about what technology you're using?
Sir, this is the same evaporative cooling technology, sir.
Okay. Thank you, Mr. Vikas. It's very interesting. I think you can stop sharing now. I
Yes,
think
Thank you.
Dr. Narendra Shah, all the speakers are over, I think.
Yes, yes, yes.
Okay. Now I will put the floor for questions. You can show your hand, raise your hand on the menu. Then I will ask the speakers to reply. Any questions people have? I will just remind the first, the talk was about using the cotton
Dr.
stalk.
Gajendra Singh has raised a hand.
Yes.
Dr. Gajendra Singh has a raised hand.
Yeah, Dr. Gajendra Singh, please.
Yes, thank you, Narendra, putting a very good team. I would like to request IIT Bombay.
The second phone must be put far away.
I'd like to request IIT Bombay to think about starting agricultural and food engineering degree program similar to IIT Kharagpur, because you are already doing so much. You're already involved, and as far as agriculture and food are concerned, they will always be there as long as humanity is there. So I find a lot of interest from the people, especially like Kavi Arya, and agriculture is also has to become high tech for to be economical and sustainable. So maybe your team should be having a brainstorming sometime within IIT and think about what can you do, because Setara, you have already a framework, you have a groundwork already done, and you have so many applications. So think about it. It's a very broad question. I don't need an answer right now, but I think about it.
Yes.
Thank you.
Yeah. Thank you, Professor. Quick reaction to that. Professor Gajendra Singh, you might recall 1995-96, that time I think you came and visited, and I was the only faculty member in Sitara that time. Now we have a team of dozen people, but the mandate is bit larger. It's called MTech in Technology and Development, or PhD in Technology and Development. So we have people from water background, energy background, and agriculture engineers. We are three: myself, Amit, and there is one gentleman who had joined from AIT. In fact, he was doing a postdoctoral research there when I went last year, and somehow we could sort of get him in our sort of umbrella here. So we are three of us, and sort of I am moving out. So Professor Amit perhaps will have to sort of get, because it does take immense amount of efforts to earlier erstwhile MHRD, for example, Ministry of, now it is called Ministry of Education, to sort of convince and tell them that like we would like to. But yes, I think thanks for instilling that confidence that we could sort of initiate such a program.
Narendra, the issue is very simple, because now agricultural field requires input from so many other disciplines. Okay, because moving away from the traditional agriculture, we have to make it competitive and sustainable. So like so much is coming from computer science area, so much is coming from electronics and all that. IIT has all of that. Okay. So you don't have to have agricultural engineers teaching agriculture engineering. Yes, agriculture engineers need to be supported by all other disciplines, okay, to make it all the kind of things we are talking about, how to bring all these new technologies applied to agriculture sector. I think that is the emphasis, because agricultural engineers do not have a training in these. So agriculture engineering really has to be a very interdisciplinary program. Okay.
Yeah.
And this is what is happening. I see in the US department, they are hiring computer science people, they have electronics people, they have economists, they are all agriculture engineering department faculty. Right. Half of them are non-agricultural engineers in many departments.
Right.
Okay.
Yeah, and just a small supportive statement, Dr. Syed, let me say this, since Professor Singh has evoked this topic. Professor Singh, number of BTech students that you know, they get kind of fed up in their own disciplines and they come to our Sitara and look for problems, you know, real life problems, you know, like what they have learned in, like that girl was saying in Kavi Arya's thing, you know, so they come and sort of, you know, explore because see, I mean, they see the relevance of agriculture in our country. And so it's a good suggestion. And I think we will see what can be sort of, you know, done. Professor Amit, do you have any thought? Yeah. Just let because he's
very quick. I think this is a very important subject matter. So Professor Singh, back in 2014, MHRD actually put a mandate for all the IITs to set up such a department. And I don't know what happened after that. Professor Shah may recall that we actually talked to chemical engineering department to set up such system here. It didn't happen though. I think, but yes, there is a need and there is also a will from our side, but political will is also needed. We'll be very happy to have something like IIT Kharagpur at IIT Bombay at some point.
Correct. Maybe
you can be better than IIT Kharagpur.
Yes.
Maybe if current president of ISAE, Dr. Indramani, if he can support IITs, any initiative that we take, and sort of as a professional association, if they can sort of, you know, support that there is a need and this can be sort of a useful pedagogy or teaching, we would really appreciate.
And we would need your guidance and support, I think, in this endeavor.
Yeah, I would like to tell my experience with IIT Bombay. I think in the year 2000, I think I met Patak, Professor Patak. I think he called me because I made the first ARM7 board. So we had a long discussion. I think with Narendra Shah, I met him also twice afterwards, even 5 years back. So I was telling him that time itself about agricultural engineering must come. And Narendra Shah actually joined as a temporary for a long time. And then finally, somehow, he's probably only guy I have seen. He made this today what Sitara is. I think I know from the beginnings I have seen, I think when he joined in the 80s, late 80s, something like that. And in between, I have seen several of the laboratories. They have a very good greenhouse work. I went and visited them. And I mentioned here also in this forum in previous talk that once I visited their computer science department, where Patak was sitting there, he came inside and saw they were discussing about making a website for farmers, where I was telling them already WhatsApp is existing with the Nasik farmers. I visited just now, came back. So they have a lot of potential. What I want to say is, and I think I have met electrical department. I remember, I don't know, Desai, Dr. Desai, he is now at, I think, somewhere else, the director.
At IIT Hyderabad, yes. He's at
yeah,
IIT.
So I met him we are talking about networking for the agriculture census. These are all, I'm talking about 15 years, 20 years now long. I think it's the correct time now. I think probably what Dr. Singh suggested, all must push through, because I see the advantage of IIT Bombay has got so much technology facilities, which unfortunately not much used according to me in many areas. But I think right now the robotics also they conduct very good, excellent. Like I'm impressed with Kavi Arya, his initiatives that he has taken. Recently, we also saw another IIT's Rupar is also taken into agricultural sciences a little bit. And I would support this Dr. Rajat Singh's view that I think IIT Bombay must come really strong, and we'll all support.
Dr. Indramani, he has maybe some thoughts on this. Dr. Indramani, could you say your views on this? What Professor Gajendra Singh evoked?
Actually, I joined late. I was in Hyderabad from last 3 days, and there was what Professor Gajendra Singh said that everybody wants now. That was basically horticulture related conference, and all discussion was about engineering. And myself and Professor Singh have been discussing it, from last many years, that this is the time when hardcore engineering knowledge of IITs and agricultural experience and knowledge of agricultural engineers in universities and in ICR institutes, should join hand in, to work by getting bracketed with. It's not like that you are doing one at one place and we are doing at another place. But what you said, and there was a mention by a participant here that 2014, there was direction to all the IITs to work on these, problem-solving areas, and particularly related to agriculture. So we at IRI, worked with IIT Kanpur, and I have been working with IIT Kanpur under NIDI program, National Initiative of Design Innovation, and that hub and spoke model, and that work was very good, and not only us, two more team, one from medical and another from textile, SBTI Kanpur, and this Medical Institute of Lucknow, all were working together, and our experience was really very good, and we developed 8-9 technologies and IIT system, and that was a MHRD sponsored program, and they realized that if we want to develop agricultural related solution, water related solution, air pollution related solution, involvement of agriculture people and agricultural engineering is very, very important. And just to share with you that team IIT recommended to MHRD that now IRI should be in hub mode and not in a spoke. And then we were given responsibility to develop and we submitted proposal. So they said that you take some NIT and some agriculture institution and work as a hub. So such experiences are very, very important. And very recently, you might be knowing that one program has been launched by government, and that is Drive DRIIV, in which this one for Delhi, similarly for all metros, that all institutions, like in Delhi, we have been asked and IITs have been asked to work together for finding out solution for major problems, as you are telling. For us, the solid waste management, air pollution, water quality, 5-6 items have been given and selected, and all institutions have been asked to work together. Even medical one and biology science, physics science, all have joined hand. So this is an era where government is also in mood that togetherness is very, very necessary, and ISA has been working for it that without involving different institutions, core engineering, core agriculture, solution is cannot be evolved. So I fully support Professor Gajendra Singh's suggestion, and not from now. I was his student in 1999. And that time he said that to join this course of ecology and sit in the first row, so that you should not, in agriculture course, you should not sit in the last, you should sit in the first row. And all 10 students were asked to sit in the first row and understand. So he said that unless you understand the patient, how can you develop any solution or any medical solution for him? So for you, the plant is patient, and you understand, and then only you can develop the engineering. So very, very important, and so 2-3 aspects are there. One, very good ambience is there, government mood is there, institution have grown up to this stage that they can collaborate. There has been respect to each other. Earlier there was a respect, like IIT might be saying, oh, agriculture, what they are doing. Now everybody is saying that agriculture is very, very important, and COVID has basically given little more emphasis on this, that agriculture is backbone. And so my submission would be that any such program is very, very important, and Dr. Shah's presence at IIT Mumbai, Dr. Tiwari's presence at IIT Kharagpur, and there are our friend Raghuvanshi in NIT. There are other in NITs and IITs people are there. This is the time to, and Murthy is there in IIT in this Indore. So this is the time to connect connect and work together. So networking and finding out solution, how IRI can be helpful to any program of IIT Mumbai or IIT Delhi, how IIT Delhi can be helpful for us. ICR has come to a decision, and they have taken on precision agriculture, a very big network project in which there is a request that please involve IITs and let us work on that. So this is really very good opportunity, and I always say that this political bill is very, very important, and this is right time that from top it is coming that engineering led agriculture is the future of this country. And Dr. Saha and other friends, this is the best opportunity to join hand and work for that, and whatever ISA can do, will do. So that is our assurance, and Professor Singh's presence and Dr. Syed and all this effort is basically to converge at a place that join hand and find out solution. So I'm always there. I could not join. Actually, I just entered home and just immediately I joined the program. I was there in Hyderabad, and Dr. Rao organized, Professor Gajendra Singh Sahab, Praveen Rao organized. It's a big program that was Dr. HP Singh and all were there, and all discussion was around engineering. So all horticulturists want engineering, agriculturists want engineering, engineers want agriculture and horticulture. So this is the time what Professor Singh is saying. Very, very important. Thank you very much.
Thank you, Dr. Indramani. I will allow one question. Dr. Caroline is for a long time before. Then I will come to Dr. Kavi Arya. Dr. Caroline, please.
Yeah. Sir, my question is to Dr. Vikash. I would like to know the capacity of the subji cooler, weight of the subji cooler, whether it can be customized, and material used for the subji cooler.
Thank you, ma'am. The material used is, we have developed a composite material which is made of 6 or 7 different materials. So, and the outer or inner body is of MS steel. The second one is currently the most demanding size is about 100 kgs of leafy vegetables. So we have other size as well, so we can customize, ma'am. And the weight is 50 kg, ma'am.
Thank you, Vikas. I would now request Kavi Arya. Please tell you raise your hand.
Yes, thanks. I just like to say that Professor Gajendra Singh has said exactly the right thing, that you need multidisciplinary work. I don't see it happening too soon in the system. Although the government has said ये करना है, आपको नया degree program बनाना है वगैरह, 3-4 साल के लिए कुछ नहीं होने वाला है. I'm offering you at the moment that we have this activity at IIT Bombay. It's a platform. eYantra is a platform to make students collaborate, and students are going to do the work. So we have one competition that trains students, and another one which is which helps them use these skills to solve real problems. And the target of this competition is the Sign Incubator at IIT Bombay. So हम क्या करते हैं? We help students articulate real problems in society, and then train them to build a prototype, and then do a business plan and do a startup. So what's happening at the moment, sir? I just like to. We are now collaborating with agricultural colleges, particularly in Rahuri and Parbhani, to get the faculties on a table. This is on Tuesday. This Tuesday, we are having a half-day workshop where we want agricultural faculty and students to come and just curate a list of useful problems, which then we'll get them to collaborate with engineering students. And within the next 6 months, you will see results. The next 6 months. Right. So if anybody is interested, may I put a link on the chat here? If anybody is interested, they can register, and maybe we can interact with them.
Okay.
Can I do that?
I will. Go ahead, please. Go ahead.
There's a form. If you're interested in joining us for this workshop, which is on Tuesday morning, half day, 10 to 1, where we will spend some time just articulating agricultural problems targeted towards 3 platforms that we've created. These platforms can solve a problem which would take you 2 years to solve in your agricultural institute. It can do it in 1 month's time. That is the challenge which I'm happy to accept. And please do join us, whoever is interested. Thank you.
Okay. You just, I think Narendra Shah, you can share the link. We'll put on the group also. Okay.
Okay.
I have Narendra Shah. You want to tell something?
Yeah, I just wanted to say that I think one of the colleagues of Dr. Indramani, who got this World Food Prize last year, Professor Ratan Lal in US, although he's a sort of a young man of 85 years, I understand, but with whom we have been interacting. One of our PhD student is consulting on soil science with him. So in the sense that we are doing activities, but to give a form, sort of, more sort of, formal structure to pedagogy, I think we would sort of make effort and look forward to it.
Narendra, the main point I got, Gajan Singh, is what I feel is there is a distance, there's a lot of distance between what you foresee in IITB as an agriculture engineering and actually in the field what is happening. Because I have visited and seen your where you have the weather station, where you have all this stuff, but in the real field is completely different. So probably I think what I emphasize rather, every time you must go to the field and talk to the farmer inside rather than only professors too, because professors are very important, scientists are important, farmers also important. The needs are important to see. Dr. Gajan Singh want to add something.
Yeah, Sayyad, actually, Narendra,
yeah,
my thinking is slightly, we don't need a conventional agricultural engineering curriculum. I think what we have been discussing in our webinar, all these new areas, especially with emphasis on urban agriculture and all that. Yes. So let us have a kind of a unique, different curriculum, okay? Yes, some traditional curriculum will be there, okay? Right. But we don't have to teach traditional plows and harrows continuously, spending so much time on those, okay? So my idea is to look at what we are talking about. What we are always talking about IoT and all these things. So let us put a new curriculum, okay, with emphasis of all these technologies which are useful to agriculture.
Yeah. Thank you. Dr. Syed, I just want to very, very quickly mention that one of the unique thing about our MTech program, and the students are appreciating, we have a 16th batch now, 9 weeks they spent in a village which has a population less than 2,000, and then they leave and they see where the shoe bites for these village people, and that's where the needs assessment comes, and often at times that students, like for example, so this is something which is very unique. Even during my BTech, I had only sort of some internship which I did in Karnal, for example, so that's very, very conventional. But like what we have, and we can bring that in and sort of, develop something. And I look forward to the input from all of you, Professor Singh and Dr. Indramani and Dr. Syed.
Narendra, for example, you have sent me some students to me. Last year you sent me Setu. Wonderful. He got excellent job in in industrial IoT. Right. No, they are very good students. Actually, he has spent time in the field because you guided them properly. Actually, what I see in many of some of the good, I'm not talking only at IITB, many institutes I find, excellent professors, they make the interaction students with the farmers directly. Actually, what I insist again, we have to have a curriculum, some part of it, to look at the farmers' current issues, okay, and then solve them. And we have to look at cost-benefit ratio of the farmer. If you go and tell them, you have this technology and use it, I think it's a bit difficult. He doesn't have money. So we have to see what is the problem, how he creates money. So we have to start from basics of what I call this, pull technology, whatever it is. I think probably the education system, IITB is excellent. What I'm saying is, probably most of the IIT, last time I met some of the conference I listened, many of them don't have agriculture background. They were talking about irrigation, automation, precision farming, drones, and etc. They are not even probably gone to the field and spent about 1 month time. So probably that we have to change. That's what I mentioned. Agriculture engineers must be given importance there in IIT, because they can help you to bind together all the technologies. Thank you.
Again,
Any
a
other?
short note. Narendra, my actually again thinking is mostly at a master's and PhD level.
Yes.
Your program doesn't have to do undergraduate BTech.
Yes.
Sure.
Let me be frank. We should admit a BTech student from agriculture engineering from all over, okay? Rauri, wherever it is, okay? They have the agriculture background, they have the agriculture engineering. But then they need an integration and a top up by the technology, which IITs are working. So integrating that, I think, will probably give us better results. So concentrating on a postgraduate program, research and innovation, okay? That
Like
kind of
AIT, like AIT does, right?
That's what you are
IIT
doing, Sikar. Yeah, AI. Well, anyway, I spent my life at AIT, so that model I'm very convinced.
Right. Yeah.
Thank you. I would like to request Dr. Mayande to say a few words, please.
Thank you, Dr. Syed. I endorse the discussion held on agriculture engineering at IITs. Dr. Gajendra Singh, Dr. Indramani has made several points. I endorse that. In fact, now agriculture is all about engineering now. Without engineering, agriculture is not going to stand at all, actually. Every facet of agriculture is engineering now. That's why IITs, as Dr. Narendra Shah mentioned, that the MHRD and all those processes will go on. We can try and jointly, etc. But I feel that in a present program, Katara, etc., in all our departments, you have theme as an agriculture. Agriculture as a continuous theme, and let all the students work on agriculture problems, so that IIT can contribute significantly in agriculture, solving agriculture problems. Very rightly, you are collaborating with Marathwada Agriculture University, Vasantrao Naik Marathwada Agriculture University, Rahuri, etc. I think Kavi Arya mentioned that you are going to have a meeting on 21st and bringing them on board. These kind of collaborations are necessary because
We lost you, Dr. Mayande. Unmute yourself. Unmute yourself. Dr. Mayande?
I don't know how I got muted automatically.
No.
Okay. So I think that's where
Again, you got unmuted.
it is happening automatically. Automatically, it is happening.
Last time also, I remember.
Okay. Yeah. I think role of IIT in agriculture sector is increasing, and Dr. Narendra Shah, I think your strength of people like you in IIT needs to be more. Maharashtra, government of Maharashtra is more relying on IIT than agriculture universities nowadays. If there is any solution is required, they contact IIT Bombay for solutions. I think that's where the role of IIT and agriculture universities have inbuilt issues that we don't have agriculture, pure engineering disciplines like electronics, chemical engineering, mechanical engineering, not very low profile. It's only agriculture and agriculture engineering, not pure engineering disciplines in agriculture university. In fact, I am saying that
Again, you're muted.
it is happening automatically. I am not doing anything. I don't know. Well, the host has to really unmute me. Keep unmuted. It is happening automatically. That we should have an independent department of pure engineering sciences, actually, so that it supplements agriculture. This is need of an hour. But I think processes will go on. But let IITs decide. At least IIT Bombay should take a lead. That let agriculture be a theme in all the disciplines, all your departments. Like computer science engineering, you have said your next year theme is agriculture. Similarly, all the departments in IITs take some students working in agriculture sector will resolve several issues. I think this is all about the discussion going on in education, but some of the issues on presentations, I would like to comment certain issues. Dr. Narendra Shah, I think compliment to you that you have converted cotton stalks into an animal feed, a wonderful technology. I think it's very useful. I think we have large number of cotton stalks burning still going on. Some stalks are being used for energy conversion, but not so much. But this kind of technology is going to be very, very useful. But only I have a couple of questions on it. What is the quality of feed that you produce from this? Second question is on economics. What is the cost of feed? These two questions will have to be resolved. I'm not expecting answers from you, but I think you are in the process of developing technology. MAPSU is a partner as well as BIF is a partner in this process. So I think jointly you can resolve this issue. Probably Rajiv Gandhi Mission on Science and Technology also is a funding partner. So I think years to come, I expect that something concrete comes out so that animal feed issues in Vidarbha region at least will be resolved, Marathwada and Vidarbha. And value addition to the cotton stocks is long awaited actually. This is altogether new use of cotton stocks for animal feed. Wonderful technology. Secondly, Mr. Amit Arora, I think.
Again, your voice again, just now, unmute. Something happening with this system.
Host is muting me automatically. Host is muting me automatically.
No, you are a co-host. You are a co-host already.
I'm getting muted automatically. Mr. Amit Arora, I think you are working with Pokhara and also Marathwada Agriculture University and the Onion Research Center. As far as onion is concerned, I think can you scale down 100 tons structure to a small structure, maybe 1 ton or 2 tons or 3 tons, to make it more economical? Because right now this 100-ton structure is too big for a small farmer in the onion growing area. So if you can scale down and make it more economical, I think that you should continue that part. 100 ton in.
Again, you are unmute, please.
I'm getting, you are muted by the host. Getting a message here.
No, you are a co-host.
I don't know how it is happening. That's my one suggestion. So the cost of technology is good. Technology is good, and the
again you are.
Because the subject-cooler, I think, is going to play a very pivotal role in because it is addressing the logistic issue. Because losses in vegetables, especially from farm to mandi till it gets to consumer, I think you can have 3-4 days storage capacity. I think that resolves the problem. So I think it's going to very, very good technology. We attempted sometimes back, but we did not go to the market. So that's what this kind of technology, very portable, zero energy vegetable preservators we developed, but we could not go to the market and export technology. But this is a startup, so it's a good challenge and good potential for this. So this is in brief, and I appeal once again, Dr. Shah, continue emphasizing that all departments in IIT should have agriculture as a theme now. I know Dr. Pathak, we are working on one of the advisory body, Maharashtra Knowledge Corporation. So we meet almost very frequently with Pathak, and he emphasizes now is was the computer science. He still works there.
Yes,
it's the computer science, and he talks a lot about agriculture now. So I think all computer science departments should work on theme of agriculture now. So thank you so much. Thank you so much.
Thank you. Dr. Narendra Shah, you raised your hand.
Yeah, so I just wanted to mention, I think in continuation with Dr. Indramani said that there is a political will, and my colleague Professor Amit Arora will narrate to you. 10 days back, we had a Maharashtra Agriculture Minister, which is a team of 12 people, you know, the Commissioner Agriculture, Secretary Agriculture, everybody came. And I think they appealed to our department to develop technologies for small scale farmers. So Professor Amit, maybe 1 or 2 lines you want to say about that? Because I wasn't there during that trip. I had to go to MPKV Rahuri to meet the Vice Chancellor there on the same day. Yeah,
sure. So Maharashtra, so State Agriculture Minister came here and we did make our presentations, the kind of things we are doing at IIT Bombay related to agriculture. And they really appreciated this, and they said that they should not stop at this level. So we need to extend this to other colleges. That is one. So just like, you know, we had the Unnat Bharat mission, so we also have now Unnat Maharashtra mission. So something like that, we should also look at how can we scale out, not just staying in IIT Bombay, but work with agriculturists, work with farmers together and develop technologies that can go out as soon as possible. So it's not just for showcasing. I mean, that's the message he was giving, and they are all ready to support us in terms of funding and all that.
Actually,
That's a really good message.
Yeah, last year, actually, I know Agriculture Minister sent to Vice Chancellor a letter saying that what are requirements. For example, the cotton harvesting and a small ginning machine like that. I got somewhere to look at that. I think they are very keen. They are giving now exactly what you have to make it. I think probably we'll always succeed. I think I would like to thank actually IIT Bombay team. It's excellent. Actually, I love the topics which are completely or very relevant to what we are today facing and what we need solutions. And I think everybody made a point. Anybody else I'll give for the last round. Anybody has anything to say, they can say now.
Syed, before we close, I think we should tell about this BIAF. We're having done the animal.
Yeah, we are. Yeah, I think we are planning. Like I told you, next week we are planning for. Let it be surprised. We are planning for. It's interesting because they are also. You see, we want to work. You see, agriculture engineering goes up to, like I told you, every walk of life in the farm. It's not only with the tractors and machinery. It's with the adding the value to the life of the people, because we should know 50% of the people are depending on the agricultural income or dependent somewhere. So we would look at their livelihood. Like I told, somebody was talking about Pokhara. They also look at people who have landless laborer, how to bring them up. So we will have interesting next time session. We are calling one of the oldest NGO, and they work on animal, for example, and they look for people uplifting. They look for, they also work for water.
Watershed management, yeah.
So, and they do a lot of work. I think we are talking with them to fix it. Probably it works out next week, or we'll work one of the days. I think next week we are fixed already with them. So we'll have interesting. Yes. We'll continue again. I think like I request once again, I request you, all of you, I'm looking for some more speakers on conservation agriculture. And because the reason is why according to me, with my little knowledge, we have to develop a lot of equipments for conservation agriculture for small marginal farmers level at least. So we have only a happy seeder and few of the equipments. So engineers have to do a lot of work on conservation agriculture. Unless we come to know what exactly happened, what is the progress. So I'll request all of you, please tell your friends, everybody, to please ask them to contribute and tell what has happened, so we can have a plan for the future. Thank you very much. With this,
Dr. Syed, for your information, I was with BIAF for 2.5 years in the beginning of my career, and worked directly with Manibhai Desai and Dr. Hegde at that time.
Wow.
So I know that organization.
Excellent.
And another unique thing, Dr. Syed, is like, for last 15-20 years, the organization is led by the president is IIT Bombay alumnus. And he not only did BTech Mechanical in IIT Bombay, but he went to IIM Ahmedabad and joined in that point in time Girish Soni in BIAF. And I'm sure, like Professor Mayande said, I think it will be an interesting session for IIT platform.
Yeah, Girish Soni is now heading the organization, and I think we are in Pune. We are at Pune to meet very frequently. We are on several advisory bodies, meet very frequently.
Sure.
So, good.
I would just like to tell Dr. Mayande that Professor Phatak is the guy who hired me at IIT Bombay, and my first job was helping him set up the distance education program at IIT Bombay.
He's always dynamic. I met him in, I think, 98 or something first time, 97, 98. And I met him before 5 years back with and he's still the same, running around everywhere.
Very energetic person. When you talk to him, you get an energy from him. He's a very energetic person.
That's very
good.
Yeah, and Professor Gajendra Singh, his cousin is somebody whom you know, who was in Bangkok, used to sort of interact with Dr. Phatak, one Dr. Phatak there. And the person whom they are mentioning about IIT Bombay Phatak is cousin of that same Dr. Phatak.
Oh, CS Phatak? Chandrasekhar Phatak?
Yes.
No, not that Phatak.
No, not
Indore Wale. He used to work in FAO for Danish. He was a scientist.
Oh, yes. He's in Canada now.
Yeah, so So he and this our DB Phatak are sort of, so.
No,
sorry, I mentioned that.
he was my student. He is in Canada now.
Okay. Yeah.
From Denmark, he came to Canada.
Yeah, and Dr. DB Phatak is Chairman Board of Governors in IIT Indore. So Dr. Indramani and this one, like I think we should, when Ganti Murthy, who is friend to Amit Arora sir, we can take benefit of, Dr. Phatak's presence there because he is the Chairman Board of Governors and might be able to, and of course, who was a colleague of Professor Kavi Arya, who mentions that he is the one who hired him, but they were colleagues together. Thank you.
Thank you. Okay. Thank you, friends. We had another wonderful evening this Saturday. We'll meet you. We'll meet again next Saturday. Every Saturday we are having this program. Thank you very much.
Okay, good night.
God bless you. Namaskar.
Good night. Good night.
Thank you very much. Good night.
Thank you.